Consider the differential equation dy dx is y plus 1 multiplied by y minus 3 over x with y equals 5 when x is 1. Using delta y as dy dx delta x with delta x equals 1, estimate the value of y when x is 3. So, x is 1, y is 5. That means that dy dx is going to be 5 plus 1, 5 minus 3 over 1. So that's 6 times 2 over 1, which is 12. So delta y is going to be dy dx times delta x, which is 12. So when x is equal to 2, having taken this step, y must be equal to 17. So dy dx would be 17 add 1, 17 take away 3, all over 2. So that gives me 18 multiplied by 14, divide that by 2, which is 126. So our delta y is going to be 126 times 1 when we go another step of 1, which is 126, and that means that when x is equal to 3, we're estimating that y is 17 add 126, which is 143. Show that the solution to the differential equation can be given as this expression here. So we have dy dx is equal to y plus 1 y minus 3 over x. So if we separate, we get 1 over y plus 1 y minus 3 dy is equal to the integral of 1 over x dx. So we need to use partial fractions here. 1 over y plus 1 y minus 3 would be a over y plus 1 plus b over y take 3, giving us 1 is a y take 3 plus b y plus 1. Take y equals 3 and we get 1 equals 4b, so b is a quarter. Take y equals negative 1 and then we get 1 is equal to negative 4a, so a is negative a quarter. So, feeding back up to here, we've got a quarter of the integral of 1 over y minus 3 take away 1 over y plus 1 dy is equal to the integral of 1 over x dx. So this one here is a quarter ln y minus 3 take away ln y plus 1 is equal to ln x plus a constant, which I'll write as ln a. And then using log laws, that gives me ln of y minus 3 over y plus 1 is ln ax. Of course there's a quarter here. Let's take that up over the other side and we get ln y minus 3 over y plus 1 is equal to 4 ln ax. And of course using a log law this 4 can come inside here, so we can say ln y minus 3 over y plus 1 is ln bx to the 4. Log equals log, so it follows that y minus 3 over y plus 1 is equal to bx to the 4. Now we want it in the form y equals. So y minus 3 would be equal to bx to the 4, y plus 1. So y minus 3 is bx to the 4y plus bx to the 4. So y minus bx to the 4y would be equal to bx to the 4 plus 3. So y into 1 minus bx to the 4 is bx to the 4 plus 3. And so y is equal to bx to the 4 plus 3. I don't know why that plus 3 is not in the right place. Let's put it there. All over 1 minus bx to the 4. Now, y is equal to 5 when x is equal to 1. So 5 is equal to b plus 3 over 1 take b. Bring this up here. 5 minus 5b is b plus 3. Rearrange, 6b is equal to 2. So b is a third. So y is going to be 1/3 x to the 4 add 3 over 1 take away 1/3 x to the 4, multiply top and bottom by 3, and we get the answer required. We want to calculate the percentage error in using the approximate technique of part A in finding the value of y when x is 3. So this was the value we got in part A, and now we have an exact solution. So what we can do is substitute x equals 3 in here. We get 3 to the 4 add 9 over 3 take away 3 to the 4. So that's going to be 3 to 4 is 81, so 81 add 9 divided by 3 take away 81. And that gives us negative 15/13. That's quite a different answer. So the percentage error we could work out as 143 take away negative 15 over 13. Now we don't need to worry about the sign there, we're just after the error. So we can make sure this is all positive and multiply that by 100%. Let's see what we get. So that's 143 add 15 over 13. Let's make sure we get it in the right place. And we're going to divide by that as well. And then we're going to multiply by 100. And I think for this one I'd like it in decimal. And that gives me 12,493%, which is a massive difference. Now, explain the error. Well, if we look at the denominator here, we have an asymptote when x is equal to the 4th root of 3. The step-by-step method doesn't pick that up at all. It's going to miss that fact altogether. So what's going to happen? Let's just graph it on here, and then it might become clear. So let's clear everything, and then we'll plot. So we've got x to the 4 add 9 divided by 3 minus x to the 4. And if we graph that, it looks like that. So what happened with our step-by-step is it just keeps going up here, and it misses the fact that this comes around like this.